Hey everybody. This is a short but thorough introduction to data wrangling in R. I'm going to be using the dplyr package and the tidyverse family of packages. If you haven't already installed that for some reason, you should do that immediately with install.packages, parenthesis quote tidyverse. You only need to do that once, but then every time you use R, every time you start up a new script, you want to get access to the functions in those packages with library tidyverse. I'm going to be doing a bunch of examples using the diamonds dataset that's included in the ggplot2 package, which also loads up with tidyverse. You can take a look at the help file with question mark diamonds, and I've also pulled it up in the viewer by typing view parenthesis diamonds. You can see we've got about 54,000 diamonds in this set. Each row is a different diamond. We've got cut, caret, color, clarity, and some quantitative measurements on their size, as well as the price. So you can imagine wanting to do a lot of different things with this set. Maybe you only want some of the columns, maybe you only want some of the rows. Maybe you want to arrange them in different ways, get summary statistics on these, or do additional calculations to create additional columns, or to modify the columns you have. So I'm going to show you how to do all of those things. We're going to subset by rows and by columns with filter and select respectively. We're going to reorder rows with arrange. We're going to modify columns or add new columns with mutate. And then we're going to handle some group summaries. As we go through all of this, I'll throw up some links to some longer form videos on some of these topics that I've already done. And I'll also give you just some signposts for some additional areas of exploration, some other dplyr verbs that I'm not really going to talk about in this vid, just for time. So let's jump in with filter. Let's subset by rows. So looking at the diamonds data set, maybe I just want the ideal cut diamonds. So let's start with that. I want to do a filter, and the first argument is going to be the name of the data set. That's going to be a trend in all of the verbs I'm going to be using today. All of these functions take as their first argument the name of the data set. And as we'll see later, this is very convenient in a lot of ways. After that, we need to say what we want to do. What's our criteria for filtering? And in this case, my criteria is going to have to do with the cut column, and I want to save only rows that have a certain value of cut. The way I denote that is cut, double equal sign, and then in quotes the thing I want. So in this case, it's ideal. I need to put it in quotes here because this is a string. It's just characters, right? So I need to let R know that I'm not talking about a variable called ideal. I actually want the values ideal. Now, if I print this out, if I hit enter right now, if I execute this, it's going to print out in my console. It's going to be ugly. I don't really want that. I'm going to rename this as diamonds. How about diamonds small? And I'll command enter to execute that. And maybe I'll put that in my viewer. Diamond. I'm going to mistype a lot in this vid, I'm sure. I'm sorry for that. All right, so there we go. You can see we only have ideal cut diamonds. Great. What else might we want to do? Well, we might want to subset by a quantitative variable. For instance, let's just take more expensive diamonds. We've got price here. So again, diamonds small. Maybe I'll just copy and paste that. I'm going to do another filter. Again, diamonds is the data set I'm working with. And my criteria now is going to be based on price. I want things that are over $10,000. So those are going to be my more expensive diamonds, right? Maybe I'll put that in the viewer. So now you can see only ones with big prices. We can do multiple criteria. So let's see here. Let's take a filter on diamonds. Oops. And let's do both of these things. Let's take cut is equal to ideal. And since I'm getting multiple arguments, maybe I'll do this vertically just for legibility. Let's also take price greater than 10,000 and see what we get. We can view that again. All of these are ideal cut diamonds. All of them have price over $10,000. So you can see just adding a comma here allows you to do sort of an and when you're doing a filter. To do an or, the syntax is slightly different. Let's do that. Maybe I'll just copy and paste this whole line here since it's pretty similar. If I want an or, instead of a comma, it's a vertical bar. And so this is going to give me all of the diamonds that are ideal or over $10,000 or both. So it's not an exclusive or. So ideal cut diamonds that are under $10,000. And if we go further on in here, somewhere down here, there'll be some diamonds that are over 10,000. I don't want to spend too much time searching, so I won't search at all. Okay, so there's a lot of different things we could do with the filter. One other thing that I'll mention, I'm not going to do examples with this, but let's just mention it. Filter for missing values. You can't just do like cut equals quote NA. That'll look for a character vector called NA. So you need to search for missing values using is.na. And if you want only values that aren't missing, you want exclamation point, which is there, is.na. So that's the not. Are things missing or are they not missing? All right, for the sake of time, I'm going to move on to select, which is going to let us choose columns within our data set. So maybe you've got a very wide data set. Maybe it's got 100, 200, 1,000 variables, 100, 200, 500 columns. And you don't want all of them. For various reasons, this might come up. So the select verb is going to help you with that. It's going to let you subset columns. You can also reorder them, and if you want, you can use it to rename your columns. So for instance, let's let diamonds small, I don't need all of that, be selected from diamonds. And let's just take cut and color. Let's make it really small. So, see, I'm using comma here again as sort of an and statement. If I do that and then view diamonds small, you can see I've just got those two columns, just the ones I named. If I reverse the order, color before cut, it reverses the order here too. Now, you can specify the columns you want in many, many, many different ways. The name for the general vocabulary for picking columns in tidyverse is tidy select syntax. I'm going to teach you just a little bit of that. So, let's take diamonds small again. And this time we'll do a select on diamonds. Let's just do the columns that we want by number. So let's just take columns 1 to 4. You can see we got the first 4 columns of diamonds, caret, cut, color, and clarity. So you can do them by name, you can do them by number. There are a lot of helper verbs, just sort of little smaller verbs that give you, they give you a little help with your select. So let me show you one of those. So in the diamonds data set, let's just get all the things that start with C. So instead of having to list out cut, color, clarity, etc., this is just going to let me pick anything that starts with C. You can see that there are 4 such columns. I'll copy and paste that to show you one more like that. There's also ends with, by the way. Another one that you might want is contains. And so contains is going to get the 4 that we had plus price. Those are the only columns in here that have a C. You can learn a lot more, by the way, about this. I'll put this up top with question mark, select, get you the whole help file on that. Lots of help there. Let's go up and remind and put a note in here that you can also do question mark filter. I think that's useful. And it's the one from the dplyr package. So obviously in this vid, I'm not going to get to everything, but this is some helpful stuff. One last one I'll do with select. Oops. I don't want starts with C. Let's just say that we have the diamonds data set. And let's say I just want to move price up front. Well, I could put price and then put all of the other ones, for instance, price, then cut, etc. But there's a helper verb for this too, and that's everything, which I do have to type correctly. And this is a function, so it gets parentheses after open and closed. And if I do this, you'll see it's the same data set, but it's got price up front, just like we want. All right, so this is once again a really deep well. There's a whole lot. Oh, I do want to show one more thing. Like suppose we just wanted to eliminate one row. Eliminate one column. So this time, I'll take diamonds. Let's just take out price. And you'll see I did that with a negative sign. So this is going to give me all the columns except for price. This new data set only has 9 columns instead of the original 10. Price has been removed. Okay, let's reorder some columns with a range. Now, as we get into this, you see that we're always having the data set as the first argument. Also, when you're doing real-world data analysis, you'll frequently want to do each of these things. You might want to do a filter by row and then only select some columns, then reorder them. You end up with a whole data analysis pipeline. And so tidyverse R is set up for this. And so I'm going to just rewrite some of this a little bit different. I'm getting to arrange, I promise. Let's just rewrite this in a different way, and I'll comment it. I'm going to use the pipe. And it's going to bother me if I keep that capitalized. So the pipe is going to be exactly the same thing as this, but it lets us write in subject, verb, object order. So the subject of my sentence is diamonds. The thing I want to do is to select. And what do I want to select? I want to take out price. Not prince, price. And again, I want to save it as diamonds small, so I'll put that in here. Okay. That's going to be exactly the same. Notice that what's happening here is it's taking the diamonds data set and passing it using this pipe as the first argument to the select command. This gets really helpful because all the dplyr verbs have a data set as their first argument. And they also output a data set. So if I wanted to put another pipe in here with, for instance, a filter command, I could. By the way, the keyboard shortcut for this pipe is Command-Shift-M. I use that shortcut probably more than any other command, any other shortcut in R. So maybe in a little bit I'll do an example where I do a filter and a select and an arrange and other things. You'll definitely see a longer pipeline where that gets useful. Okay, so arrange lets us, well, arrange arrange the rows that we have in different order. So for instance, maybe I want the colors to be in order. Right now they're all kind of jumbled up. Or maybe I want the carets from small to large. So let's make a new name for this, diamonds, ARR for arranged. And I'm going to start using the pipe. I'm going to take diamonds, and then I'm going to arrange it. And hear the way I'm reading that. Take diamonds and then arrange it by whatever criteria. So really, all I need to do is specify the criteria. Let's arrange it by color to start. And we can view that. There we go. And you can see color D, and then if we go further down, we'll have color E, F, G, H. So it's going alphabetically in ascending order, sort of from A to Z. Let's see here. I'll just copy and paste for a second because I'm not going to be changing a whole lot. This time, I'm going to arrange it by caret. And you can guess what that'll do. Ascending carets. You can arrange by multiple things, sort of in order. So I'm going to arrange first by color and then by caret. So all the D's are first, starting with the lowest carets, but I stick with D as the caret gets larger. Now we can reverse that order and get the columns arranged in a different way. So first let's arrange by caret and then by color. Okay, so the smallest are first, but among the 0.2 caret diamonds, first we've got the D's, then the E's, and so on. And you can arrange by 2, 3, 4, 5 criteria, however many you like. I think that's really all I want to do. Oh wait, no, there is one more thing I want to do with arrange. Because you might not just want the smallest caret diamonds up front. You might want the biggest up front. So there's a couple ways to do that. The first is to wrap the thing in DESC for descending. And let's view that. There we go. Okay, so now the biggest diamonds are first. So we've got this 5 caret diamond. That's a pretty big diamond. It's only got a fair cut though. And then the numbers get smaller and smaller. One other way that you could do that, by the way, is instead of DESC, you can put a negative sign in caret. That ends up being exactly equivalent. Before I move on, let me just show you one other smaller dplyr verb, and that's glimpse. So let's do glimpse of diamonds arranged. And you can see that puts it makes it print out in a way that's a little bit more legible, sometimes fits in a little better with a markdown document, for instance. You can see the number of rows, the number of columns. You can see each of the variable names, its type, and the first few values. And the first few values are chosen so that they fit in with the console window. So if I rerun Glimpse after I've resized the console window there, I get a slightly different printout. I get slightly more values. So that's kind of nice. Just a handy verb to have around in general. Okay, let's modify and add columns with mutate. So there's lots of things we might want to do here. Clean up a little bit. For instance, carats are a unit of measurement that's wonderful for jewelers, but if you're like me, you don't necessarily have great intuition as to how much a carat is. So maybe you want to add a column here that's going to convert carats to, say, grams. And I happen to have looked up before that a carat is 0.2 grams. So let's make that modification and add a column to this data set with carat weight, with the mass of the diamonds in grams. So how about diamonds new? I don't know. I'm not thinking too hard about my variable names today. I'm going to take diamonds, and I'm going to pipe it into the mutate command. That's our new one. So again, diamonds now is passed as the first argument to the mutate command. So take the diamonds data set and mutate it so that we have a new column. That's what mutate is going to do. And how about mass G will be the name of our new column. And it's going to be defined to be 0.20 times a carat, because each carat is 0.2 grams. And let's just glimpse this, how about? Since we now have glimpse. Yeah, R does want you to spell things right. I guess that's a good thing. You can see you've got mass in grams. So this 0.23 carat diamond has a mass of 0.046 grams. Let's see here. A couple other things we might want to do. Maybe I'll just copy and paste this whole thing because I'll just stick with it and I'll add new things. You can add more than one column at a time. So mass G equals, how about something like price per carat? So what I'm going to do is I'm going to take price, and every row, the value I get for price, I want to divide it by the value I get for carat. So these two vectors, mass G and price and carat, have the same length. And so R is just going to go through component-wise. 326 divided by 0.23, 326 divided by 0.21, etc. And it's going to add a new column on that basis. And if we glimpse it, you can see you've got your price per carat of your diamond. Lovely. Copy and paste again. We can modify column names while we're at it. So let's see here. You know what? I think I actually want to copy and paste the larger set that I made. Let's hold on to our price per carat one. Let's modify the cut column. And I'm going to do it using an old-fashioned function toLower. And so what this is going to do is it's going to take all the values in the vector and make them lowercase. So notice I put cut equals. So R is going to see that that refers to an existing column, and it's just going to overwrite it. So this can be useful sometimes. For instance, if I have no more use for these uppercased things, this would be good. But it is kind of throwing away some information potentially. So there's not necessarily an easy way to get things back, depending on how your workflow is going. And so if I do my glimpse, you can see that now my cuts are all lowercase. Let's see here. One last thing I want to show with mutate. We talked about price, right? And we filtered earlier for price being above a certain value. So I think I want to do one thing. I want to make a new column like that. So how about I make a column called expensive? How about YN for yes, no? Or maybe like TF. I don't know. I don't want to think too hard about my column names today. They're not always ideal, I know. So I'm just going to give it a logical condition. I'm going to say, let's call something expensive if the price is over $10,000. For me, expensive is much lower than that, but that's a different thing entirely. Let's just take this on as it's given. Okay, so the price of $326 is not considered expensive. Similarly for these next few entries. This is a logical vector. It's all going to be trues and falses. Great. So that's all that I want to do with mutate. Let's see. I want to mention a couple others that are useful. Maybe I'll put a section in here. By the way, I'm getting a new section with Command-Shift-R. How about just other smaller verbs? This isn't going to be a complete list, but it'll be a few others that you might investigate on your own. I'll do this as a comment. No, you know what? I'll do it for help files. So you might want to check out slice, like slice max and stuff. There's a few functions in that family that are worth knowing. Subsetting rows using their position or other things. So this would subset by the biggest value of a variable or the biggest few values of a variable. I also recommend checking out bind rows. So this is where you have a couple data frames that are the same and that they have the same columns and you just want to latch them together. I am not going to talk about left joining data sets that have that refer to similar information, the same observations, but may have different columns. It can be really helpful. So check that out. Rename, just to rename columns. That's a nice one. And I'll also mention case when, and I won't say anything really about that right now, but it's a generalized vectorized if-else, and that can be really useful inside of your mutate commands. So highly recommended. Okay, grouped summaries. Someone once told me that all of data science, or 90% of data science, comes down to grouped summaries. It's an exaggeration, but not by too much. Here we're going to really see the power of the pipe. We're going to look at this diamonds data set, and we're going to say, okay, what kind of carat weights are we seeing for the different cuts of diamonds or the different colors of diamonds? How do prices break down in those ways? So what we're trying to do is to essentially group this data set by, say, cut or color, and then get some summary information on some other variable. I think the easiest way to understand this is just to dive in and do it. So let me do that. I'm going to take diamonds. I'm going to pipe it into group by. And I want to group by, let's start with cut. And if I just hit enter there, not much is going to happen. I'll just print it out. You don't really see the difference. I've still got the same data frame, the same tibble. Same data frames and tibbles are basically the same thing for most purposes. Underneath the hood, tibbles are a little easier to work with. The only difference is that now this data frame has a groups attribute. And I imagine this like if it were an Excel spreadsheet, that all the ideal cut diamonds are highlighted in one color, all the premium diamonds are highlighted in another. So then when I take that data set and put it in a summarize command, like so, whatever command I give it, whatever summary data I ask for will happen group-wise. It'll be done for the ideal diamonds, the premium diamonds, the good diamonds, all separately. So for instance, I can get the mean price. And I can just print this out because it's a really small data frame. For each cut of diamond, fair, good, very good, premium, ideal, it went through, took that subset of data frame, and computed the mean price. Lovely. Now, that doesn't look the best, mean price as a column. Let's fix that. Let's call this column average price, for instance. Oops, I need an equal sign, not a dot. There we go. You can see I got average price. We can do more than one summary at a time. So we can, for instance, get the standard deviation of price. So that's SD of price. And there we got two columns in our output data frame. Fabulous. We can group by more than one thing at a time. So let's see here. Maybe I'll just copy and paste this one. Let's break things down not just by cut, but also by color. Okay, so this is slightly larger. Now we have 35 rows, and you can see that it is first grouped by cut. So I've got the fair cuts all together, then the good cuts all together. And the second grouping is by color. And then it gave me those summary statistics for the sort of two-way table, for the fair cut diamonds of color D only, then for the fair cut diamonds of color E only. A very useful helper verb there when you're doing summary information is n parenthesis parenthesis, and that just gives you counts. So here I can see there's 163 diamonds that are fair cut that have color D. This is particularly important because I'm doing these summary statistics. I don't know how significant or important, I should say, this average really is. Is that for 1,000,000 diamonds? Is it for 5 diamonds? Makes a big difference. Maybe I'll call that column count. Okay. Sometimes you just want counts. You don't care about these other statistics in here. And you can just use the count variable directly. So to be consistent, let me use the pipe. I'll pipe diamonds into count. Like so. And now I just have to say what I want to count by. So I could count by cut. I can count by cut and color. So now I just have those ends. So let me just put a comment. That's counts only. Let's see here. I also can group by groups that I make up on the fly. Let me show you what I mean. So let me take diamonds, and I want to group it. Now, I just want these expensive and non-expensive diamonds. Maybe I don't want to create a whole column that says expensive or not. Let's group it by whether price is greater than 10,000, like so. And then I can do kind of the same summary as before. Maybe I'll just copy and paste that, if I can. That should work. There we go. Make a little bit wider so you can see it. So yeah, there we go. So now here's my group. I have diamonds that are not over 10,000. I have diamonds that are over 10,000. I have their average prices and so on. Nice, right? Next thing I want to do is to get a better column name there. So instead of price over 10,000, let's call it expensive. And you can see that fixed this column name right here. All right, I think that's good enough for a quick, rapid introduction to data wrangling in R using the dplyr package. Like I say, I hope that you've gotten a bunch out of this, and please check out some of my other videos to go into these in a little bit more depth.